Position, velocity, acceleration. Back a couple units ago, do you remember that we would do a derivative? I'd give you a position function. And I'd say, like, what's the initial velocity? Or what's the acceleration of this thing? And we did a derivative, yep, to get velocity function. And then another derivative, which would be second derivative of the original. And we get acceleration. Well, now that we have integrals and antiderivatives, we can go backwards. We can start here, do the integral, get back to v, do another integral, get back to s. And guys, this is actually how we develop some of these formulas. So on the first one, I just give you a function to start, but on this one down here, this is how we actually come up with the formulas. So what I just wrote up there is what I said right here. So I'm just going to jump into an example. So again, a couple of units ago, I started with s, and we got v and a. This we're starting with a and getting back to v and t. So find the velocity and position functions if here's our acceleration function. And then we have some initial conditions. Velocity at 0 is 5 and position at 0 is 4. Okay, so what I'm going to do is go backwards. I'm going to do an integral to both sides. The integral antiderivative of a of t will take me back to v of t. On the right side, I'll do the antiderivatives. For sine, it is negative cosine t. Yeah. Then I've got for 2t, I got plus t squared. Don't forget a plus c. These are indefinite integrals. There's no number on these. So we have to have a plus c. This is an initial value question. I'm going to plug in 0 for time and 5 for velocity. So we know v of 0 is 5. So I'm solving for c. I'm going to put 5 in there. I'm going to put 0 in for t. And solve for c. All right, so cosine of 0. What's that going to be?
-1.
Cosine right here at 0. 1, yeah, that's the 1, 0, right, is the starting point. And so cosine of 0 is 1, the exponent of 1. Now there's a negative sign in front, so it's negative 1. This is 0 plus c. And now to finish up for c, we add 1, so we'll have 6 equals c. Got it. I will now fill in my final equation for velocity. V of t equals negative cosine t plus t squared plus 6. So that was the first part they wanted. What is v of t? We found it. It's this. From here, I'm just going to repeat because they want s of t, and the integral of velocity will take me back up to position. So I'm just going to repeat. Integral of both sides. This one will now be position, s of t. It's an s. Okay, antiderivative here. I bring down the negative, and then antiderivative of cosine is just positive sign. Plus, then here I've got power rule, t cubed over 3 plus 6t and plus c. All right. Again, they give us some initial conditions here. So at a time of 0, position's 4. So I'm putting 4 in here, and 0 in. Well, for this one, I'm just going to write. Let's just write it here. I'm plugging 0 in for all of these. So sine of 0 is 0. So this one's 0. Because all the rest are 0, right? 0 cubed, 6 times 0. So basically all we're left with is that plus c is going to be 4. All those ended up being 0 there. So I'm going to write my final position function. S of t equals negative sine t plus t cubed over 3 plus the 6t. And then c was 4, plus 4. Okay, so we've seen that example. The only thing is just putting it in the context of position, velocity, acceleration. We've seen that type of question before. Initial value problems. I'm now going to do one that relates it to, remember like the particle questions or a falling body question? Again, I think you have 3 or 4. Any thoughts on the first one, though? All right, well, let's move on. I'm going to do basically the same thing, but they're going to give us less information. You're not going to see up here v of 0 equals, what was the last one, 5. You're not going to see it here. But they actually do give us enough information. This is going to be a falling body question. So we are like on a roof. Somebody's here. They're dropping a ball. They're tossing a ball up, a rock, an object, something like that. Same questions as before. Find the velocity and position functions. We have a body falling from a height of 100 meters. And we're going to do 2 questions under each of these conditions. Now, here's all we need to start. You guys, remember earlier in the year when we did this, I said, I can't show you now why it's these values, because they always end up being the same value, but I'm going to show you right now. Okay, this is how we get those final values. I'll show you in a minute. It all starts with acceleration. So we know near the Earth, it's this. Feet, it's negative. It's 32 feet per second squared. This is probably the one you're used to. Like if you did physics, you probably do meters. Yeah. Okay. So first condition, we're just an object starts falling from a rest position. So we're just dropping it. So I'm going to put A here. This is just going to be A. We're holding up a rock or some object and dropping it. So let me start. The acceleration function, A of t, equals negative 9.8. That's acceleration. It's just constant gravity acting on us, negative 9.8. Okay, now, please don't do this. Every year I say don't do it. I always have students say negative 9.8 t. You don't need t. It's just start with a number. Okay, acceleration near the Earth is always a constant number. And it's negative 2 because it's acting downward. So negative 9.8. Okay, guys, from there, it's the same as before. I'm going to find the velocity and position. Integral of A of t, acceleration is velocity, B of t. And over here, it's negative 9.8 plus c. Now, they didn't write in v of 0 equals something, but anybody have a guess what we can put in for v of t and t? How about this? It starts falling from a rest position. 0 for both. Really, what we know is at a time of 0, v of 0, the velocity is 0. Right, starting from rest. So right as we start to release it, time of 0, it wasn't moving. So the velocity is 0. Even though they didn't write it, we can get this from the question. Nice, so both of these are 0. Here, I'm just going to fill it in like this. 0 goes there, so this will be 0, and therefore we just have c left over. So c is 0. So let me write my final velocity function, v of t, negative 9.8 t. If you want to write plus 0, you can. It's just c is 0, so you don't. It's 0. We can simplify to this. Okay, now I'm going to do it once more. Integral both sides to get my. So that's one answer. To get position though, integral of velocity is position. All right, now here we'll do the power rule. Let me do this one off to the side. I bring the negative 9.8 down. Then this is to the first power. So I'm going to do power rule. It'll be t squared over 2. 9.8 divided by 2, though, is 4.9. Negative 4.9 t squared plus c. This is the number I was talking about. Remember earlier in the year we had this, or maybe in physics class, you always end up with this equation for a falling body, negative 4.9 t squared, and then some other numbers, sure. Yeah, this is why. You work backwards from acceleration, you're always going to get this, the negative 4.9 t squared for a position function. Okay, what about this time? What can I put in? So I'm solving for c. What can I put in for position and time? 0 for time. What about position? 100. So we look up here. It just depends on the height of whatever you're starting at. Start at a height of 100 meters. Yeah. So this is 100. If it's okay with you, again, I'm just going to say this is like I did over here. I put in 0 there. All of this becomes 0. 0 squared is 0. Times that is 0. So c is 100. And I just fill that in. And here's my final position function, the negative 4.9 t squared plus 100. Now something else somebody asked earlier, which I thought was a good question, is wasn't there like kind of a formula for what these values are? Yeah, you can rely on that too. If you remember, this is always, the c value is the constant. That's always your starting height. So if you remember that, you can always say, all right, I need 100 at the end for position. I'm going to do one more with this where we're throwing the rock or object, whatever. Okay. So anything to add on this one? So each of these questions kind of builds on itself just slightly. No? Okay. Well, an object this time is propelled downward. We're throwing it down. So we do have an initial velocity of 1. Because we're throwing it down, it'll be negative. If it's throwing it upward, it would be positive 1. I'm going to go back and start with the acceleration. It's just negative 9.8, not negative 9.8 t. Okay, and I'm going to, I got to start here because my velocity function is going to be different here. So I'm going to do an integral and get back to v of t on the left. And here it's again negative 9.8 t plus c. Oh, too much. Okay, so now the initial velocity, v of 0, we're throwing it down at an initial velocity of 1 meter per second. It's a light toss. Just take 1 second to go a meter. That's basically just we're tossing it. Well, it's just kind of like, 1 meter in a second. I don't know. So, yeah, now we saw, okay, v of 0. So a time of 0. So I'm just going to put in 0 for t. The velocity is negative 1. I'm putting in 0 here, so this is gone. It's just 0, and then c. So my final velocity function then is negative 9.8 t minus 1. So you can see there is a difference on this one. We actually have a c value that's not 0. All right, one more time. Integral of v of t is s of t. And we just did this one, okay? There's same as before, negative 9.8 t. It becomes the negative 4.9 t squared. Here the antiderivative of negative 1 is negative t plus c. All right, and now we're going back, same as the last one. The initial height is 100, the height of the building. So we really know s of 0 is 100. I don't know if I wrote that off. That's what we really know. I didn't write it, but yeah, s of 0 is 100. So I'm putting in 100 here and putting in 0 for t. And these are all going to become 0. So we're left with c. Final equation, s of t equals the negative 4.9 t squared minus t plus 100. So you see a very slight difference just throwing it at 1 meter per second, and we get definitely some different equations here with this. That thrown in becomes that there, the initial velocity. Okay, so anything else about position, velocity, acceleration, or using integrals to come up with them? Okay, just as a recap, Unit 3, I gave you s of t. We did derivatives to get to acceleration. Now I'm going to give you a of t, or acceleration, that might be all you know. And you can work backwards to get up to S of t. So, cool. Now, second thing I wanted to say is related to that kind of motion. It's motion with displacement and distance. So flip the page, I'm going to explain that, and we'll do two examples to finish up. This is called integral as net change. Now, I want to review displacement. Remember that? Displacement, the concept was like, I walk forward 3 steps, and I walk backwards 1 step, so my displacement is 2. Because I went forward 3, backwards 1. So
the original starting point.
start to end, I went 2. Now my total distance, so that would be displacement. My total distance though was 3 and then 1 backwards. So really what I did, this one back here was really 3 plus a negative 1, and we got 2. All right. Distance though was really 3 plus the absolute value of negative 1. So we included that as a positive 1 and got 4. I say that here because all we're going to do is translate that to integrals and do a similar thing as I just did. Okay, what we're going to do, if we have the velocity function, this is v of t, this graph. Well, if I knew, just as before, velocity, the integral will get us back to position, right? Well, what we're going to do, though, is a definite integral from A to, so an integral from A to B. What it's going to do is it's going to get the area under the curve, right? It gives us a number, area under the curve. And that will be displacement, just from A to B. The distance, though, is we treat anything that goes below the x-axis, we do an absolute value, just like what I did up here. So we will do an absolute value, we'll turn it positive, and that will get us the total distance. So, anyway, I mean, integral going backwards from V will get us position, but if we do definite integral, it actually adds up the area under the curve, gets us displacement and distance. So that's nice. So I say here, for distance, we take this one and we make it positive. For displacement, we keep it as negative, anything below the x-axis. Should I try one? Just see how it looks on these, and then see if there's questions. Okay, well, displacement, so we're going to find displacement and distance for this function. It's an object modeled by this function. We're in the interval 0 to 10, so that's our A and B. I'm going to first do displacement. It's simply the integral from A to B, 0 to 10, of the function v of t, which is 49 minus 9.8t. In dt, right? We write that as just the symbol that means what variable we're integrating in respect to. All right, so I'm going to do FTC1. Find an antiderivative, capital F of t. So the antiderivative for 49 is 49t minus, now we kind of just saw this one, didn't we? 9.8t. It becomes the 4.9t squared. So you didn't remember, you just have to redo that, but maybe we just did it, negative 4.9t squared. Okay. Now this FTC1 is just f of 10, capital F of 10, minus f of 0. I'm plugging in 10. So I'm plugging 10 here. 49 times 10 is 490. Minus, still plugging in 10. 4.9 times 10 squared, that's 100. 4.9 times 100. It's also 490. So f of 10 will be 0. Minus, let's plug in 0 now. This is going to be an easy one. 0 and 0. So we get 0 minus 0, which is 0. Here's our displacement. Not always going to be 0, but for this one, it did end up being that. Okay, now here's what we need to do for distance. We actually need to find where the velocity function is going below the x-axis. That's how we know it changes, and we're going to break it up into multiple integrals. So I need to find that. I need to find the x-intercept for v of t. So I'm going to do v of t equal to 0 to get the x-intercept. That's how I'll know where to break it up. Okay, so what was it? 49 minus 9.8 t. I'm saying that equals 0. Adding 9.8 t to both sides, so we'll get here 49 equals 9.8 t. And then divide by 9.8 and we'll get 5. Now, do not always assume, I usually make some, there's a lot of practice I made where it is not right in the middle. Sometimes students will look at this and say, oh, I got to break it up into 0 to 5 and 5 to 10. It happened to be that on this one. What it doesn't, it could have easily been 0 to 2 and 2 to 10. So don't always assume it's halfway. This one it just ended up being that. Okay, now I am going to do one other thing before I do my integrals. I want to make sure that it's actually changing. This is unit 5, max and min. Yes. And
Sorry.
no, you're fine. So what I'm going to do, I'm going to plug in a test value. Right? Remember these test values? Plug in like 4 and 6 into v of t. Just make sure that it actually does change. So it goes below the x-axis. All right, well, 4, where am I? I can plug in 4 here. This is v of t. 9.8 times 4 is going to be roughly about 38. It's going to be less than 40, 39 or something, about 39. 49 minus 39, it's going to be a positive number. Plug in 6, this is going to be roughly about 60, 58, 59. 49 minus 60 is going to be a negative number. It does change. All right, now that's all that's left is just we broke it up at 5. So we do the same integral here. We got to break it up at 5. So here's what I'm doing. Integral from 0 to 5 of v of t plus, I'm adding them, plus the integral from 5 to 10. Okay, and really, as we see up here, there's absolute value around both these. You can put them around now, you can wait till the end. Okay, usually I just wait till the end, and if the number is negative, I make it positive. But if you like, you can go ahead and put these around just to make sure. Now, it looks like a lot of work. We've actually already done many of these. So let me set this one up. F of 5 minus f of 0. Right? That's what this one would be. FTC1. Okay, plus, then this one's going to be f of 10 minus f of 5. We actually have already done f of 10 and f of 0. Right, they're both 0. So I'm going to fill some things in. That one's 0, this one's 0. All I need is compute f of 5. That's it. So let's put in 5. This is for v of t. So it's the same, I didn't do it again. I didn't do it again, guys, but it's the same antiderivative we already did. So let's plug in 5. 49 times 5. Let's do it here, actually. 49 times 5 minus, we got 4.9, and then 5 squared, right? 122.5. So that's f of 5. 122.5. And it's over here, 122.5. We sum these, we'll subtract these, it's 122.5. Now this one, we get negative 122.5. This is where you change it to positive. So really all along here, I could have had absolute value. This one's already positive though. This one is negative though. So I change it to a positive 122.5. And then all the way down, I just need to add these two separate integrals. 122.5 plus 122.5 is 2, let's see, 45. Now this is a distance, same as displacement. I should have had units over here. Just there are no units given, so I'm just going to write U for units. Okay. I'm going to do one more, but just a quick review. Displacement, just integral A to B. Distance, though, you got to break it up. It's not always in the middle. Could be. You got to break it up into multiple intervals.
What is your representation?
Units, centimeters, feet. Nice to have a unit. One last comment. Some people don't even do displacement on the left, which is fine. They do distance, and then when they get down to here, they do distance by changing it to positive, like I did, and then they do displacement by just doing this and keeping this one negative. And you would get 0. So I'm fine with that. I like to do it separately first, but you could also just do distance and get displacement from it. Okay, last one. Any thoughts on that one, though? Anything else I can answer? Okay. Let's do one more. I have a trig one here. Displacement and distance, same thing. We got another object modeled by this function, velocity function. Again, this is only if you have velocity. I should say this too. If I did this last one as an indefinite integral, I would get this plus c. That'd be great if we had that, but we had no initial condition to solve for c. Didn't work. But we have this other theorem that helps us be able to find distance and displacement. Okay, we are on an interval from 0 to 2 pi. That's a to b. Displacement is going to be the integral from 0 to 2 pi for my velocity function 2 cosine t dt. Let's see, so let's do an antiderivative, capital F of t. I bring the 2 down. Cosine of t, the antiderivative is just sine, no negatives. Sine of t. Okay, so now I'm going to do f of 2 pi minus f of 0. Now, before you do any work here, do you know 0 and 2 pi on the unit circle? 0 is here and 2 pi is also there. So it doesn't matter what we're going to get here, it's going to be 0. Because we're going to get something and then subtract the same thing. So, sure. Now I will go ahead and do it. 2 pi, sine of 2 pi is 0. Times 2 is 0. Sine of 0 is 0. Times 2 is 0. So we do get 0 units. Again, disclaimer, not always 0. I like these two examples, it's just the displacement ends up being 0. Okay, so let's do distance. It is, I gotta break it up. I need to set the velocity function equal to 0 to find the x-intercepts for velocity. That'll tell me how to break it down. Let's see, so I'm gonna set 2 cosine t equal to 0. Divide by 2, both sides. So I'll get cosine t equals 0. Okay, and now we do use our knowledge of the unit circle. Where is the cosine of what value is 0? Along here, what? Cosine of what is 0? This is, again, where is the x-coordinate 0? Right, the x-coordinate there is 0, 0, 1. So that's at pi over 2. Anything else? 3 pi over 2. 0, negative 1 is that point down there. So we've got pi over 2 and 3 pi over 2. Now I'm going to do a very quick check to make sure that these all change sign, I will choose maybe, let's see, how about pi in the middle? Pi over 4 down here. Oh, pi over 4. Maybe 7 pi over 4 here. Let's just make sure it changes sign in each of these. I'm plugging them into the velocity function, which is just the 2 cosine t. Let's start with pi. Cosine of pi is -1. X squared there. So 2 times -1, this will be -2. That's negative. Pi over 4, when I plug in pi over 4 here, it'll be 2 times, and then cosine of pi over 4, radical 2 over 2. All we need, though, is just that it's positive or negative. It's positive. Same with 7 pi over 4. Cosine here in the 4th quadrant will be positive. Right, it'll actually still be radical 2 over 2. So it just verifies all of these are good. They do change sign there. All right. So I just need to break up my integral. And yes, this time I have 2 of these x intercepts. I need 3 integrals this time. Just broken up twice. So the total distance will be the following. It'll be the integral from 0 is where we start to the first one, pi over 2, or b of t. That's the first one. Plus, then we'll go pi over 2 to 3 pi over 2. It's basically additivity property. Breaking it up. Plus, then we'll go 3 pi over 2 to the end. So 3 pi over 2 to 2 pi. For b of t. Alright. Okay, it looks like a lot to do, but we already have the antiderivative. We already know f of 2 pi and 0. We'll only have to fill in, I think, 2 more. Just figure out 2 more. Okay, so I'm breaking it up. Let me write in what each of these are. This one's going to be f of pi over 2 minus f of 0. By the way, I like to write it out. I know some of you, that's fine. You don't have to. I just have to write it out. This one is going to be f of 3 pi over 2 minus f of pi over 2. And the last one will be f of 2 pi minus f of 3 pi over 2. Okay. Let's see. I knew 0, right? 0 and 2 pi. We already did them. It was 0. So this one's going to be minus 0. This one we need both of those still. F of 2 pi, though, we know is 0. So all I need to compute is f of pi over 2 and f of 3 pi over 2. So let's go back up. Let me plug in pi over 2 here into capital F, antiderivative. So what's sine of pi over 2? It's the y coordinate there. 1, yeah. So it's going to be 2, still coming up times this is 1. And so we get 2. That was for this, and one other one right there. Let me do f of 3 pi over 2 now. So it's 2, and then sine of 3 pi over 2. So bring the 2 down. What's sine of 3 pi over 2? Sine, that was cosine. Sine is the y coordinate. -1 now, yeah. So it's 2 times -1, which is -2. So right here, I got to put a -2. This one's 0 minus a -2. I'll work that out in a second. And there we go. I plugged in just 2 more than I needed. So this integral is 2. This integral is -4. And this integral plus 2, 0 minus -2 plus 2 is 2. Well, but okay, so if you didn't want to do displacement first, you could do this, and then displacement is just adding them all together it'd be 0. Okay, but distance, remember, you got to make absolute value. All of these are really absolute value. That one was already positive. This one, though, you got to make positive. And this one was already positive as well. Now we add them up, and it's 8. Yeah, so don't forget to do that. You could just do that whole thing, and then when you get to the end, do them together. That's displacement. Make all of them positive. That's distance.